Good morning, everybody. I hope you're still doing well. Wanted to start today's lesson with, as we would do if we were in school, with our bell work. So here's our bell work. I want you to go ahead and pause the video and then go ahead and FOIL this expression that I put on the board. So pause the video now, take no more than 5 minutes and FOIL it, express it in simplest terms. Go. Okay, let's check if you did that right. Okay, remember our FOIL method from back in the day stands for multiply the first two terms together, the outside two terms, the inside terms, and then the last two terms. So let's go ahead and do that. The first two terms are x times x, which gives me x squared. Then the two outside terms, x times 4, or actually negative 4 I should say, is minus 4x. Then the two inside terms, 4 times x is 4x, positive this time. And then finally the two last terms, that's a plus 4 times a minus 4, and gives me negative 16. Then hopefully you will have combined like terms, and this is especially sweet here since I have a different color. A minus 4x and a plus 4x that are opposites and they cancel out. So, which gives me my final answer, x squared minus 16. All right, that's from back in the day, and you should really be okay with that. If not, I'll go ahead and post some some old materials on Moodle so you can maybe brush up on that. But see, here's the truth. I got an email last night from a student after he did my GIZMO, and he said, look, have we done this before? I don't think we have. And I responded to him and said, no, we haven't, but the truth is we have, which is the 180-degree exact opposite of what we're fixing to do. Because we're getting close to using the third method of solving quadratic equations, which is we're going to solve them by factoring. Well, factoring is basically unfoiling. Up until this point, our goal was to kill all the parentheses and come up with as neat and as short an expression possible. Whether it has quadratics or not, we didn't care. We just said, hey, no parentheses. We want to go back on that. We actually, this x squared minus 16 is actually number 4, the very last practice problem on your GIZMO worksheet. So if you have that in front of you, that'd be great. It's the last page, it's number 4 on it. And you're being asked to factor this expression, which means you're being asked to go back to this one. And if you look at it, you can kind of intuitively figure this one out, because you're going to realize that, oh, I needed to multiply two x's together, and there's a negative 16. How can I get that? Oh, positive 4 times negative 4. So you could probably figure this one out. But then on the GIZMO, on the last page of your GIZMO worksheet, if you look at numbers 1, 2, and 3, it's not as easy anymore. It's funny that they would give you the easy one last and then the other ones first. But so what I wanted to do today is we're not going to quite yet solve quadratic equations with factoring. We're just going to practice the factoring that gets us ready to then solve them. Because after we figure out the factoring, there's only one teeny little step to where we can use it very efficiently to solve entire quadratic equations. So I thought the best thing to do would be to ask you all to get this the GIZMO worksheet out that I gave you the other day, and we'll pick two problems, work them out, talk about them, and then I'll give you a couple days to practice around on some problems that I'll post on Moodle. So without further ado, let's just go to shall we say number 1, on that's the last page of your GIZMO worksheet. I'm gonna write it on my little board and then we'll work it together. So it is this dude right here, x squared plus 7x plus 12. I hope everybody can see that. That's a big old plus, and that's a big old plus too. So if you don't have the GIZMO in front of you, I'll let you slide. This is number 1. This is your GIZMO problem number 1. So this one is not as nice and neat as the other one we just did. So let me give you a couple of checkpoints. Did you wanna pass before you can actually factor this? Number 1 is, and I wrote it on the board here, is your quadratic equation, and I know this is technically not an equation, but let's just pretend it is. Is it in standard form? And this was on our big whiteboard in the classroom. This is the standard form of a quadratic equation. ax squared plus bx plus c equals 0. Remember, a and b are coefficients, and a c is a constant. So in short, they're numbers in front of the x's, except the c, which is by its lonesome little self here. For instance, this is an example of a quadratic equation. So if things are in this order, and once it's an actual equation, it also needs to equal 0. But most importantly, if my terms are in this order, I can factor it. The other requirement, the other checkpoint is there a number in front of the x squared? So in other words, what is my a coefficient? And for us to be able to factor it right now, it needs to be 1. So in other words, I don't want to see a number in front of the x squared, which means it's a 1 times x squared. If those two things are given, then we can actually work this. And it's really just, you need to ask yourself one question. Because as I said, there's no a coefficient. The only two numbers left here are my b coefficient and my c constant. B coefficient is 7, constant is 12. So here's the question. The question is, what two numbers can you think of that when multiplied together give you 12? Those same two numbers when added together need to give you 7. So the way I do is I think about the factors of 12, because that's the product. So which two numbers when I multiply them together give me 12? There's a few options. I have 12 times 1, 6 times 2, or 3 times 4. So now what I've got to do is I've got to check which of these pairings, when I add them together, give me 7. Let's try the first one. 12 times 1 is 12, but 12 plus 1 is not 7. So that one doesn't work. Let's try the other one. 2 times 6 is 12, but 2 plus 6 is not 7. So that pairing doesn't work either. 3 and 4. 3 times 4 is 12, and 3 plus 4 is 7. So that's my winner here. Okay, and once I figure that out, I'm really done, because my end result is always going to look the same. I'm going to get those two binomials in parentheses that back in the day I would FOIL. So basically what we're doing here is we're unfoiling a quadratic equation. So again, 3 and 4 are my magic factors. And this is it. This is the answer, okay? There's one teeny tiny little step that we still need to take to solve this for the roots of my quadratic equation. I don't want to talk about that today. We just want to practice the factoring. But if you don't believe me, if you don't believe that these two things on the board are the same thing, go ahead and FOIL the two binomials, and you should get the quadratic expression at the top. So that's one example. Let's look at another one. Let's maybe look at number 3. Number 3 says x squared minus 9x plus 18. All right, our job, factor it. So we're going to say, two checkpoints. First of all, is it in standard form? Yes, it is. Good job. Second checkpoint, is the leading coefficient 1? Yes, it is. There's no number from the x squared. Gotta be a 1. Can't be a 0, because if it were 0, the whole x squared would be gone. So now let's go ahead and factor it. Let's think of those two numbers. It's a little harder here because I got a negative 9 here. So, but let's start with the, oops, sorry, that's supposed to be an 8, not an 18. 8. Which two numbers, when I multiply them together, make 8? 2 and 4, 2 times 4, or 1 times 8? Okay, that'd be great. See, if all of this was positive, I would say I'll pick 1 and 8, because 8 times 1 is 8, and 8 plus 1 is 9. So that would work, except my 9's negative. So I got to take that into account too. But at this point, you want to remember old Aunt Sally, and Aunt Sally said that if you multiply two negatives together, they would still make a positive. But if you add two negatives together, it just gets more negative, right? So we can take advantage of that. Think of -1 and -8. -1 times -8 is +8. -1 plus -8 is the same thing as -1 minus 8, and it gives me -9. So in this case, my two factors are negative. They're -1 and -8. And once I realize that, again, I'm done. So my answer would be this. And again, the quadratic equation is not solved, strictly speaking, but we're okay with that right now because our objective today is just to learn the factoring skills to make that happen. So what I will do is, I know y'all gonna give me a hard time if I don't do number 2, because I did 1, I did 3, I did 4. Why did we not do 2? And why do we have to go out of order? But that's just the way I am. So, but let's do 2 as well. Okay, so let's do 2 real quick. 2 on GIZMO sheet, last page. So number 2 is x squared minus 7x minus 18. All right, so checkpoints real quick. I'm not going to say it. I'm going to let you check it. Is it doable? Yes, it is, because it's in standard form, and the leading coefficient, the a coefficient, is 1. So I can still do it. So let's look at my -18. I'm going to think of two numbers that when I multiply them together get me -18. And what are those two numbers? Well, the factors are really either 18 and 1 or 2 and 9. But I got to make it -18. So one of those two numbers needs to be negative. Not both of them, because if both of them were negative, you'd get +18. So Aunt Sally rules, I tell you. The question is which one's negative. So let's see. As far as the -18 is concerned, we really don't care which one's negative. But I have to add them together and be able to make -7. So problem is, if I said, oh, it was -2 plus 9, I'd get +7, and that's not what I want. I want -7. So I'm going to make the bigger number, the 9, negative, and add the 2 positive to it. So in other words, what I'm trying to tell you here is -9 times 2 is -18. -9 plus 2 is -7. So those are my two factors. Got to make sure you make the 9 the -1 and the 2 the +1, because otherwise the addition is not going to work. Okay, so here's my answer for this one. X minus 9 times x plus 2. And again, we're going to leave it at this. We're not going to solve them for sure, for quite yet, the whole quadratic equation. We're just going to factor it. So, and I'm going to leave you with this. What I'll do is I'll post a worksheet on Moodle. It has 40 problems on it. See if you can do a few out of the first 20. Okay, don't worry about 21 and so forth. I'll post the answers along with it. They're going to be on the second page, but just play around with them. All the first 20 problems should be in the correct order in standard form, but you need to check anyway. And so just play around with it and see if you can solve them. They should all be solvable. If there's any questions, email me. I'm going to give you, today's Monday, I'm going to give you until Wednesday before I post the next video. And if you have any questions, please do ask them, because they kind of help me prepare for the next lesson here. So And I guess today's exit ticket is just going to have to be another dad joke, right? So here you go. Did you know that the first French fries were not cooked in France? Because that's really true. They were cooked in Greece. Again, if you don't get that, email me. I'll explain it to you. Stay safe, people. Stay healthy. Do some math, and I'll see you on Wednesday.